Hi everyone. So today we'll be trying to build a dictionary or hash map in Julia. The inspiration for this is John's video on building a hash map from scratch in Rust. So we'll basically be doing the same thing here, but in Julia. Okay, sorry. So yeah, let's get started. So this is the standard repository where I put all my Julia project, and we will be using a particular tool which is called pkg templates. pkg templates to get started with a basic project skeleton, which is a bit more full than the classic thing you get from pkg generate. So if you use the generate command like this, you can generate a new package, but it's recreating everything very basic, a very thin skeleton. What we want is to get PKG. We want something a bit more complete. Okay. So the first thing we need is create a template from this. Templates. How do we use? So this is the constructor for a template, and as we see, this is only taking keyword arguments, so everything is optional, and we're just going to modify the options we don't like. The things we're going to modify is we're going to first create an array of template of plugin, and inside we're template we're going to use the, let's say, the Travis plugin and the codecov maybe, yeah. Codecov, yeah. So this is going to be my plugins. Alright, and from that we can create a new template. So the keyword arguments is, so we're going to modify user, that's going to be me, authors, also me. The rest stays as is, so host license is fine, directory is going to be here, then dev is going to be false, SSH is going to be true, plugins is going to be plugins. Okay. Alright, so we have a template. So from this I think that generate, yeah, we have a generate function. Let's add a question mark to see how does it work. Okay, it works with either the package name and template or the other way around, so they should probably settle on one of the two only, but well. So let's generate a new package from our template. How did we call template? Yeah, template. And so we hashtags, yeah. Okay, let's call it that way. So it's basically initializing a new project with everything we need. So a repository, a remote on GitHub, and so on. So let's go into that project. Okay, let's see what we have. So we have a license, manifest, project toml, readme, the source, and the test. Okay, let's open that in Atom to get the Juno IDE. Great, and from this we're also gonna, so first thing we're gonna do is open the Julia standard library documentation, because we want to see how the data structures are explained, especially we're interested in dictionaries here. So any collection is something you iterate on, so you can pull values from your collection. Okay, makes sense. The basic way to do it is using the iterate function, so that's how you define things. You define the iteration protocol, and then the for I in iterator or for I in collection is the sugar on top of it. Okay, So basic way of defining this is with that. Okay, we're gonna need this later. So that's the test, and here we have the module, and we're gonna create first two files. First one will be hash. First one will be bucket, and the second one will be hash dict. So let's say this is bucket. Yeah, we're gonna use this later. Okay. So the first thing I wanted to do is go to dictionary and see what are we supposed to have from the dictionary. What can we expect? How does it behave? So we can always apparently get a dictionary from any iterator here. Okay, that's interesting. So for example, we can get a dictionary from a vector of tuples or from a vector of pairs. Okay. So what I'm gonna do is use the examples and create a new folder which is gonna be called examples. And from here have our whole examples folder. Okay. And in example we're gonna replace this with import and then d equals dot let's call it hash dict. Or we're gonna export it, so using hash dict, so we don't have to use the qualified name like this. Yeah, so this is something that is supposed to work when we define our hash dict, and this, the second one, will be with this constructor. So this is also supposed to work. So we could put this in tests, but I guess tests would be more testing all our features, including the internals, while examples is going to be more of a run through. So you can just to demonstrate that things work like this or like that. Okay. Let's get back to our source. So we have roughly a skeleton here. Or we could also put this in a test. Construction. Okay. So this is gonna export only one thing. A structure called hash dict. We haven't defined it yet, so, and we haven't even created the file, which we're gonna do right now. Okay, I think this should work. So let's get started with the hash dict. The hash dict is going to be a structure parameterized by a key type and a value type. And for now, it's going to contain some stuff that we don't know. And from we're going to start with this. No, let's start with this actually. So it's going to contain some buckets, which would be the vector of bucket, and bucket will also be parameterized by key and value. So vector here is a heap allocated container, and each bucket is going to be where values or where key values go when they have the same hash. Okay. So now buckets. A bucket of key and value is going to contain a bunch of items. Also, for now we'll do it heap allocated. So it's going to be a vector of, let's say, tuple of key and values. Okay, that should be it for now. So now we're supposed to have something that works. So if we run our test, this is gonna fail. We can prove it. Yes, so we're now in the environment, so we can run our tests, and this is gonna fail. Yes, because we don't have any constructor for hashdate which takes directly the tuples of these pairs or these tuples or these pairs. We only define how the dictionary is supposed to behave, but not how it's constructed. So now we have to create some constructors for it. So first, let's add some documentation for it. Let's start with some good practices. So hash dict behavior stores key value pairs by key hash. Oops. Okay. So what we need here to make our test pass is a constructor, because we need to be able to define some hash dict from something that's not always a vector of bucket. So let's hop. So it means we have to be able to take as items directly. And items can be, for example, a vector of tuple of key and value, or key and value. We don't have any type constraints on the keys or the values. It can be anything. And yes, and this is supposed to return our dict. For that we have, I think we need a base size here. Why a base size? Let's be because when we create a dictionary, it has a fixed size, and at each element it's going to be a bucket. So this is going to be a keyword argument if we create an empty dict. So base size is have this size like this. It always has to be an integer. So this is creating. Let's create the buckets. KV with nothing inside, or in base size. So we're gonna create an array of buckets which will contain nothing. Okay, and then we can create a hash dict like this. Return hash dict kv of these buckets. So it's going to be the empty constructor. And then here, if we take items directly, we can also provide a base size. I don't think I wanted 2014. Yeah, I wanted that. That's better. So the best thing to do here, I guess, is to create an empty dict. With base size equals base size, and populate the elements. So for item in items D. So we're gonna add the item here. d of so each item is actually a key and a value. D of key equals value and return D. Okay. Alright. So we have a constructors now. I think we just don't have this the set operation, so we don't know yet how to add an element to our dictionary. Okay. But to add an element to the dictionary, we first have to know how to add it to the bucket. Okay. So the first thing we'll do is iterate over the bucket. Yes, we have our iterate here. So we'll use multiple dispatch to implement base.iterate on the type, which is a bucket. So we'll create a new definition of iterate, which works only for a new signature which has not been given before. So base iterate over a bucket. So it has to return, if we look at the definition on top, it has to return either nothing in case we are finished with the iteration, or a tuple, which will be the value, so the value pulled out of the collection and the new state, and then this state is going to be passed again to the iterate function the next time. So base iterate of b is going to be so yeah, if the items, if this is empty, see, return nothing, because if this is empty, the iteration is over. Otherwise, it means we have at least one element. So we can return the first element, and we have to return a tuple with the first element and the index at the second place. The index at the second place is 2. So it's going to be our state, and our state of the iteration is just going to be the index on the items at which we are at this point. Okay, so and now function base.iterate with b bucket and as int, that's our state. So that's the second possible signature here. And so this is returning the if, always the edge case is first, if b.items, if the length of is smaller than state, it means we can't access state. It means we are finished with iterating. Yeah. Otherwise, we return items of a state. So that's the new value, and then state plus 1. That's the next state. Okay. So we now know how to iterate. Well, here maybe I'll leave this for later, and for now I'll just add a test set, which is just a convenient way to group your tests in Julia. So you can have a test set with a given name, and then it pretty prints everything when you run the test. So we construction and iteration. Okay. We're gonna have to import this, because bucket is not gonna be exported, definitely not. Bucket of the items. First item will be 1, 2. Second item will be 2, 8. So this bucket will be of type bucket with k is int and value is also int. Okay. So for v in bucket, we're basically testing iteration here. Let's test. So key is supposed to be 1 or 2. And the values are supposed to be 2 or 8. Alright, let's run our tests. Oops, nope. Hashtag 11, let's check that. Yeah. Oh yeah, here we forgot to. Oops, no. Where? Did we forget it somewhere else? No, not here at least. No, it's fine. Okay. Bucket construction iteration expression. What exactly? So this failed, huh? Oh no, yeah, of course it failed. This is supposed to be a value. And this failed again. Ugh, yes, of course. These two are values and this is a key. Okay, yeah, forgive me. Yeah, okay, all good. So we now have our basic test passing with some iteration over buckets. So that was fairly easy. Unlike Rust, we don't have to create a new type for iterators. We can just iterate with the state itself, which is fairly convenient. So we don't have a type that is mutating itself over the iteration, because iteration does not belong to the type. It belongs to the external world, so to speak, because we're using this external state just hanging around. So everything just stays immutable. Okay. So we can now iterate over bucket, and what we need to do now is getting an item over a bucket and setting an item over a bucket. Okay. So we'll start with set index because we need it. Set index with a bang because it's a mutating function. So set index bucket. So the key is going to be, yeah, let's constrain the type here. Value is going to be v where kv. So here we are constraining the type of the key that we are passed and the value that we are passed to be corresponding to the type parameters of a bucket. It does make sense. Okay. So the two possibilities here is that if the key does not exist, then we're going to push it to the bucket. If it does exist, then we're going to replace the value. Okay. So for the each index of bucket.items, if key and value are going to be, nope, not key, well, we'll call these key and value, and then k and v are going to be the one we get from the bucket of I. If k equals key, then beta items I, so we're going to set index this time on equals value, and we're going for now we're going to return nothing. And we're going to see after what do normal dictionaries return from that. Okay, so, and if we don't find it, then it's not there and we have to push it. So push, so we push on the bucket's items a new tuple key value. No, sorry, key and value. And we also return nothing. Okay. It's not crashing. We can add some tests for this. Maybe not in the same. Well, let's put it in the same. So we have a bucket with 2 items. So we'll say so base.setIndex is strictly equivalent. So base.setIndex collection index val is strictly equivalent to doing collection idx equal val. These two things are equivalent. It's just sugar. So if you define it, you cannot define it with a sugar. You need to define with a 17th line style. But then in your test, for example, you can use that, which is fairly convenient. Okay. So what we want here is we want to set at index, let's say 8, the value 33. And now we can test. Oh, and we don't have collection, it's called B. Test that the bucket at the key 8 is equal to 33. Thing is, we haven't defined the other operation here, which is this one, and this is called base get index. It's exactly the same mechanics. Base dot get index. So we get the index of a bucket kb at key k kb. So for key val kv in without items, we're going to return so if k equals key, return v. So if we've gone through everything and there's nothing here, we need to throw a key error. Key not in collection, not in hashtag, not in bucket, not in collection. Yeah. Okay. So now in our test, we can test that this is correct. Oops, yeah. Key 8 not found in collection. Look at that. So it means that this operation failed here. Interesting. Or maybe not. Maybe it's the other. So the good thing is we're just gonna use some fairly advanced debugging technique and print and everything, or maybe not. No, maybe we can just figure out what's going on. So base set index. Well, let us work in an interactive fashion. That's the main advantage of Julia over some other programming languages, is that you can just can just work your way through the REPL in a very interactive fashion, and that's a huge advantage, and especially since in that case it doesn't come at big performance cost or null performance cost compared to the best in class. So we have this, and then we want to see if I do add 4 and 5. Whoops. So adding at 4 the value 5 should work. You're supposed to return nothing in that case, but interesting. Huh. Okay, so the set index. Oh, wait, I see what's going on. I think we pushed at some point. Alright, wait, that's not supposed to happen. Oh, I think, yeah. In that case, if we... Yes, that's an error. So we have an error here. That's supposed to be key value. So that's the first thing. So key value. This, yeah, this works here. Okay. So we now have this. So if we do a 5, this works. Okay. So now the test is supposed to pass that. B of 8. Oh, did I typo this? Okay. What a genius. Yeah, we still have key 8 not in collection. Let's just print our way through this. Oh, did I define? Let's check what's the documentation for base.getIndex. That's fine. Oh, okay, it's set index collection, value and key. Huh. Well, today I learned this. I think I always get the order wrong. So it means in the bucket here, that's moving this and that. Value key, yes. This was getting things wrong. And this should work now. Oh yeah, I need to remove my my info here. Oops. Okay, sorry about that. Okay, the other thing I wanted to check is if I have a dictionary. Let's say of int and I value equals, what does setting an index return? 533. Oops. 5 equals 33. What is value? It's the value. Okay, so we return the value in both cases. Okay, so here return value. Okay, that's a good thing to know. Okay, so we have our test almost ready. The ones we commented out are here, and I think so this is still failing because we haven't defined anything for hashtag itself. We only have worked with buckets. Our bucket is almost ready, and now we have. So now we create an empty hashtag, and for each one of them, d of k. Yeah, we have not defined setting the index for the dictionary itself. That's what we need to do. Set index for dict kv. So the value of type v and the key of type k. So the first thing to do in that case is get the hash. Yeah, maybe we should also know the base size of our dictionary. So we're going to store the base size information in the dictionary itself. I hope we didn't break anything. And then df. So key hash, it was just hash of the key. Wasn't too hard. And we have to the index is going to be key hash, which is an integer modulo the dictionary dot base size. Okay, I think it should work. And then the buckets of the dictionary at index k. So this is going to be our bracket, and on the bucket we set the index at key as value, and we just return this. Okay, that looks wonderful. I think should work fairly well now. Of course they don't look well. Yeah, of course they don't. No mention with pair. That's exactly right. We did not define this because it's very convenient to initialize a dictionary from pairs. It's a nice syntax for this with the arrow like this. So a pair is just a structure with a first and a second, and it's parentalized by the type of the first and the second, and you can create it with first, second, like this. So it's fairly convenient, and we're gonna add it to our dictionary initialization. So it's exactly the same as this one, but with vector of pair key value for I think you can destructure a pair like this. Let's try pair 1 5. Okay, first, second, F S equals P F S. It does work. Okay, so we don't need to recollect the vector of pairs into a vector of tuple, so we avoid allocating a full new vector for this, which will be awful for construction time.
There's one last thing we need. If you remember the examples we wrote, they're not quite right yet. We have this first d1, which is constructed from a vector of tuples, so this is fine, we have done it. But then we have d2, which is constructed from multiple arguments, each one being a pair. So for that we'll need an additional constructor using var_arg, and that's what we're gonna do. So yes, let's construct this argument here. So we'll basically take the same thing as a vector of pairs, but we'll replace it with var_arg. So items here instead of vector will be a var_arg of pair, and let's check. So that's, let's quit that. If you check the documentation for var_arg, it's taking as type parameter the type of the multiple arguments, or yeah, let's say the maximum type, the most generic type for all the arguments, and some number, some n, which can be a type parameter itself, even if it's a number and not a type. This number is the number of variable arguments, variadic arguments, sorry. So here, yes, we will ignore the n, so it would be like writing n where n, but you can just ignore it here. So we take variadic arguments, which are all pairs of kv, with a base size, since this is still a constructor, we still want to construct properly, and we're going to return the construction of a hash dict. So the basic thing to do would be to collect variable arguments, so this would put them all in an array, but I'm not sure that's something we want, because yeah, it's really not ideal. We don't want to put everything in. Yeah, that's really not ideal. So I guess for now the only acceptable code will be to copy this, and so this will be the code we need for any iterator. So items here could be any iterator, so that's a bit of a bother that we need that. But on the other hand, we cannot either put items back in a variable arguments, because we don't know the size, and this might stress the compiler too much. So what we do here is exactly the same thing. We construct a dict with a base size, and iterating over the items, over the pairs, we return, we set index of the dictionary at the key on the value, and we return the. Okay. So now the examples should work, in the sense that they should not at least error. Okay, and that's it. So we'll just commit that now and stop here for today. We haven't tested the verbal arguments. Maybe we should do that. Okay, let's test first, and then we'll add and okay. Oh, this is tested. Okay, so this is exactly the same thing as the example. I think we have a get index, so we can test basically that d of a, oops, no, not like that, a equals d2 of a equals 1, and then the same thing for b equals 2. That should be it. Let's test. Oops, no, we don't. We might have, yeah, we didn't define getting x, of course. Okay, we'll just do that and then finish. Hashtag. Oh no, have we even set? Okay, yeah. So we can just widely copy paste this here, because it's going to be almost the same code for get index, which is the sugar for D for getting a value at D of K. So that's what getIndex is doing. So we're getting the index of a hash date, and we're getting it for a key K, or a KV. Okay. So key hash is the height of a key, the index is this, and then we return bucket key. I hope we have defined get index over a bucket. We'll check that now before running the test. Yes, we have. So the test should now work. And they do. Alright, so it means variadic constructor and get index.
So, putting it all back together, what do we have now? Our whole structure with the examples, the sources, and some few tests in run tests. So what we can do is maybe complete a bit the examples now. We'll add some additional set index, so some additional mutations or additions in the dictionaries. So in D1, let's say. So we'll iterate over an array of KV with so the keys being strings as before and values being ints. As for this vector of tuples, string int, yeah, let's say this one, so we'll also have the HKs, let's say, of an empty string, which is also a valid key. We'll add dk equals v, and we'll just use assert instead of test because we don't have a test package here. So we'll just use assert to say now dk has to be equal to v because we just added. So this example again is not testing things properly, it's just showing how it's supposed to work. Yeah, we need to use global D here because it's a D in the global scope. Okay, so if we now run the examples, it's fine, it does not error. Well, it would if the assert was found to be false. So yeah, I guess we get here, we can commit this last tiny thing, and then we'll be good. We'll stop for now. After committing, just let me know what you thought of this first draft of a tutorial. We'll continue next time with more iterators, more advanced stuff on the dictionary itself. Obviously there's lots of things from the Rust port that we're not gonna show here because we don't have the same semantics for talking about mutations, ownership, and so on as in Rust. We don't need all of that, we just take values as it is.